This schematic on Teknic's website shows a ClearPath system with its accessories, required and optional. Each accessory has a small question mark by it. When you click, it shows useful information. This is helpful, but if you want even more detail, keep watching. We're going to discuss each accessory one by one. You can use your own power supply or get one from Teknic. ClearPath fractional horsepower motors will run from 24 to 75 volts DC, but we usually recommend using 75 volts because more voltage gives you more power for the same amount of current, which usually means smaller motors for any given application, saving space and money. Teknic's IPC 75-volt power supplies have been designed for the unique power requirements of motor drives. Among these, high peak power reserve and the ability to handle regenerated energy. The IPC supplies are available in both a lower power open chassis design and a higher power fully enclosed design. Compared to the open chassis model, the fully enclosed IPC supply has more continuous power, more ability to absorb a motor's regenerated energy, and a finger-safe enclosure to protect against electrical shock and physical damage. The amount of electrical power you need for a ClearPath-driven machine is highly dependent on the exact application and the motor quantities and their sizes. So it's almost impossible to say exactly how much supply power you need for a given application, but here are some helpful hints. From the higher power enclosed supply, you can always run at least one ClearPath motor of any size in any application. And from the lower power open chassis supply, you can almost always run one ClearPath motor of most sizes in most applications. That said, you can usually run any two motors from the higher power supply and two smaller motors from the lower power supply. In machines with smaller motors, and when the motors are used intermittently and/or not at the same time, it's possible to run 4 motors, or even more in certain cases, from the lower power supply, or 6 or more from the higher power supply. Given the large number of variables in a multi-axis machine, you'll have to test thoroughly to see how many motors you can reliably connect to one supply. But remember that by the laws of thermodynamics, you can't get more, or even the same, mechanical power out of your motors than the DC electrical power you put in. Both supplies can be run from single-phase 95 to 125 volts AC or single-phase 190 to 250 volts AC, 50 to 60 Hertz. For people who want to run off the lower AC voltage range, common when you're first experimenting with a motor at your desk or bench, we offer a pre-wired AC line cable. This cable has an 8-pin Molex MiniFit Junior connector on one end and a standard US 120-volt 3-prong AC plug on the other. If you want to run off the higher line voltage, you can cut off the 3-prong connector and rewire it to your desired high voltage connector. But you must make sure to remove or cut the jumper wire in the Molex connector, or you will damage the power supply. Exactly which supply you'll use in your application will depend on your mechanical power requirements and whether the power supply will be mounted inside the machine's enclosure. When you're developing your machine, however, we recommend you use the fully enclosed supply for maximum power and safety. Next, you need a few cables. The first two you can make using tools and components readily available online, from DigiKey, for example. But Teknic also offers these cables if you prefer to get them pre-made or don't want to buy the tools you need to make them. The third, a USB cable, you probably have already, but Teknic offers these too. The first cable, the DC power cable, comes in 2 different lengths, a 10-foot and a 55-foot, but length is not the only difference. The 10-foot DC power cable has a 4-pin Molex MiniFit Junior connector, overmolded for dust and water resistance, on the end that connects to the motor. And on the other end, it has a 2-pin Molex Sabre connector that plugs directly into a Teknic IPC series power supply. You can cut off this connector if you're going to wire to a different power supply. The 55-foot cable is long enough for just about any application, but because it's so long, we expect that most people will cut it down to exactly the length they need. That's why we put 4-pin overmolded motor connectors on both ends, so after you cut it, you'll end up with a second cable of the remaining length for free. Terminate the cut end as needed for your power supply. If you want to connect to a Teknic power supply with this longer cable, you'll need to crimp on a Molex Sabre connector. The next cable is the controller cable. It connects ClearPath to your digital control signals. Teknic offers 2 controller cable options to choose from. The first is a 10-foot cable. It has 8-pin Molex MiniFit Junior connectors on both ends. The connector for the motor end is overmolded for water and dust resistance. The other end has a regular connector that we use to test each cable at our factory, but most people will cut it off to connect the individual wires to their control signals. The 55-foot cable has overmolded connectors on both ends, allowing you to cut it into 2 cables, each with an overmolded connector at the motor end. If you want to make your own controller cable or DC power cable, you'll find all the required connector part numbers in the ClearPath user manual, as well as part numbers for the necessary tools. Don't try to make these cables without the proper tools. You'll almost certainly end up with flaky connections and frustration. The third cable is the USB setup cable. This cable plugs into the back of the ClearPath motor and into a Windows PC running Teknic's free Motor Setup Program, or MSP. This cable is a 10-foot standard USB A to micro B cable. It's only needed during auto-tuning and setup, and it's then disconnected from the motor. You probably have one of these cables lying around somewhere, but this cable is nice because it's 10 feet long, which is convenient when you can't get the PC close to your machine. It's also a high-quality data cable that won't have noise or connector issues. To summarize, you will need a DC power supply between 24 and 75 volts, with enough continuous power for your application and extra peak power if you want fast accelerations, and an AC power cable. A DC power cable to connect ClearPath to your DC power supply, a controller cable to connect your ClearPath motor to your digital control signals, and a USB setup cable to connect to your Windows PC during motor setup. The first optional accessory is a ClearPath Power 4-Hub, a board that distributes DC bus power and logic backup power to up to 4 DC input ClearPath motors. You can connect 1 or 2 hubs to a single IPC or other power supply, and distribute DC power to up to 4 ClearPath motors from each. This is an easy way to go from 2 motors to as many as 8 on one IPC supply, assuming you have enough power. A power hub also routes user-supplied 24 volts DC into the attached motors. If DC bus power is interrupted, let's say because your machine cuts hazardous AC power upon an emergency stop, the hub will continue to keep the motor's processor awake. ClearPath will continue to keep track of its actual position as well as its commanded position. When bus power is restored, each axis will automatically move at a user-defined speed to its proper position as commanded by your application. This automatic position recovery feature makes sure each axis is always where your controller expects it to be and eliminates the need for rehoming after bus power is interrupted. For each Power 4-hub, you'll need a couple of cables. A PC-SBR-72 DC power cable, which has a Molex Sabre connector on both ends, and a 24-volt DC power cable to connect your user-supplied 24-volt DC power. You'll also still need the DC power cable mentioned earlier, one for each motor, but now it runs from the motor to the power hub instead of directly to the power supply. In summary, in addition to a DC power cable for each motor and a 24-volt supply, you need one each of these 2 cables for each power hub you use. ClearPath motors natively use digital control signals for best noise immunity, but some applications still use analog control signals. The analog send unit, ASU-FR510, converts 0 to 10 volt or 4 to 20 milliamp analog signals into a noise-immune digital command that can be transmitted longer distances without fear of noise corruption. The ASU goes in between your control signals and ClearPath, so instead of one controller cable, you'll want two. You'll also need an analog signal cable and a DC power cable for the user-supplied 24-volt power. So, to get continuously variable control of a ClearPath motor using analog signals, use an ASU-FR510 analog send unit along with two controller cables, one analog I/O cable, and a 24-volt power cable to connect to your user-supplied power source. Finally, there's a component you might want to add, but probably shouldn't: a shaft key. Mechanisms are sometimes coupled to motor shafts with a combination of a shaft key and a set screw. This sort of fastening is marginally okay for single-direction constant velocity applications, but with ClearPath's ability to start, stop, and reverse with high power and precision, you want something better. After years of seeing every fastening method under the sun, we've found that modern specialty adhesives, for example Loctite retaining adhesive for cylindrical components, are an excellent solution. Used properly, it holds extremely well, but components can still be easily removed with a heat gun. Clamp-style couplings are also an excellent choice. Contact Teknic for further information, and if you still want to use a key as backup, see the user manual for proper dimensions and tolerances.